Okay. Hello, friends. Welcome to 360DigiTMG. Earlier, we are discussing about the foundation models. We have discussed about previous few models. So let's discuss rest of the foundation models. So this is it. First is our Electra model, which is efficiently learning with a discriminative token reconstruction algorithm. Is a powerful pre-trained language model, which is developed by Google AI. It stands out for its efficient training method and impressive performance on various NLP tasks. It is having bidirectional transformer encoder, which is similar to that of BERT. It is having generative and discriminative training. Like Electra employs a two-stage training process. In the first stage, it generates corrupted version of the input text, and in the second text, it discriminates between the real and the corrupted tokens, learning to understand the language without explicitly predicting the missing words in it. Okay, so then there is a discriminator network. A discriminator network will have both original and corrupted tokens as an input, and then what it will do, it will predict whether a token is real or generated one. This process helps Electra refine its understanding of real language patterns. Then key parameters. Here in the key parameters, the model size is trained on 355 million parameters to a large versions of 330 billion parameters. The numbers of layer it has been trained on 24 to 148 layers. Then there is training data. It is trained on a massive data sets of text and code, which includes books, articles, or code repositories. And as we know, the eventual aim, the use case of it, and it can be used for question answering, text summarization, text classification, natural language generation, machine translation, and so on and so forth. So this is some of the use cases. Okay. Then there is switch transformer. The switch transformer is a fascinating deep learning architecture that brings significant advantages to an LLM. Its first of it is scalability. The switch transformer can effectively scale to trillions of patterns without major performance drop. This allows for building highly powerful LLMs without excessive computational resources. Then efficiency. The mixture of expert, that is MOE mechanism, dynamically selects specified expert layer for each token within the inputs. This reduces the overall computational cost and improves interference speed compared to that of the traditional transformer. Okay, then there are performance wise. So switch transformer has achieved state-of-art results on wide range of NLP tasks, including all these question answering, summarization, code generations, and various creative text formats. Then there is flexibility. The dynamic selection of experts allow the model to adapt to different tasks and input types, potentially leading to broader range of applications and better conceptual understanding. So these are some of the use cases of switch transformers. It can be used for natural language understanding. It can be used for code generation, creative text generation, research and development areas. Okay, so this is all about switch transformer, and it can be used for it has a key component. So the key component of switch transformer is based on encoder-decoder architecture. Okay, then the mixture of expert. So the mechanism is defining feature of switch transformer. It consists of multiple expert layers, each specializing in different aspects of language processing. During interference, the model dynamically selects and combines a subset of experts for each token, reducing the computational cost and improving its efficiency. Then, parameter sharing. To manage the massive parameter count effectively, Swiss Transformer utilizes parameter sharing within the expert layers. Then there is gating network. This component within the MOE mechanism determines which expert layers are most relevant for each tokens, ensuring efficient and context-aware selection. Then there is DeBerta. DeBerta is a foundation LLM model excelling in various NLP tasks. The key features are bidirectional encoder architecture, similar to BERT. DeBerta utilizes a bidirectional transformer encoder, allowing it to understand the context from both previous and subsequent words. Relative position bias. DeBerta employs a unique relative position bias mechanism that improves modeling of long-range dependencies to model like BERT. Okay, like if there are more like full theory of full like paragraph of that text. So for like dependency, long range dependencies in that, we can use the DeBerta model. Okay, then efficient training. DeBerta incorporates innovative training methods that reduces the computational cost and memory requirement, making it more efficient to train and deploy as compared to that of large LLM. Okay, so these are some of the benefits of it. Okay, and these are the model sizes. DeBerta is the model size of DeBerta are in base model, large model, V2 XL model. So the DeBerta base model has trained on 1.5 billion parameters, and it has been having 12 layers. Okay, then DeBerta large model is having trained on 4 billion parameters and is having 24 layers. Then DeBerta V2 XL model is trained on 15 billion parameters and it is having 48 layers in it. Then the training methods of it. Masked language modeling, that is MLM, the model predicts missing words in the text sequence, enhancing its ability to understand the context and relationship between the words. Then there is input token sequence length. So it has been having token length. So the total token length is 512. Okay. So then there is Starling LMB. The LLM model developed by researchers at the University of California, Berkeley, trained on a massive data sets of text and code. This established a unique style of training using reinforcement learning from AI feedback, that is RLAIF. It interacts with another AI to learn about health and harmlessness. Currently available in two sizes, that is 7 billion and 11 billion. 7 billion is called as alpha version and 11 billion is preview version. What makes Starling LMB special? So it focuses on helpfulness and harmlessness. Okay, the reinforcement learning from AI feedback, which is RLAIF, training focuses on generating the informative, relevant, unbiased responses, leading to more trustworthy and reliable output. Okay, then there is strong performance on the benchmarks. Okay, it is having strong performance in the MT benchmarks, even outperforming the GPT-4 in some areas, which showcasing its language understanding and generation capabilities. Then there is open source availability. The researchers have released part of the model and training data on Hugging Face, and encouraging the further research and development. Overall, we can see this model in future years, in coming years, okay? Then there is Starling LM. Then the transformer-based, like many advanced LLMs, Starling relies on transformer architecture. The powerful neural network architecture excels at processing the sequential data like text, allowing it to analyze relationship and context within the language. Okay. Then it depends on what encoder-decoder architecture. What encoder will do? Encoder will process the input text. It will capture its meaning and context. And then what decoder will do? Decoder will generate the output based on the text, on the encoder's information. Okay. Then there is multi-head attention. The mechanism allows the model to focus on different types of inputs at different times, improving its understanding of massive relationships. Then there is pre-trained on massive data sets. Yes, Starling has been trained on vast corpus of text and code, providing it with a strong foundation for comprehending and generating the languages. Then there is Cypher. Cypher 7B beta is a fascinating example of LLM focused on helpfulness and alignment with human preferences. A 7 billion parameter, which is having 7 billion parameter. It is trained on 7 billion parameter. Generative pre-trained transformer, GPT, like language model. Okay. Fine-tuned version of Mistral 7B, trained on mix of public and synthetic data set. Okay. Then utilizes a direct preference optimization where human chose their preferred output. Human can choose their preferred output. Okay. Guiding the model towards helpfulness. Okay. Then there are some of the key features of it. Like it has having a strong performance. Okay. It has been shown in the MT benchmark having good results, giving good results in it. Okay. Then focuses on helpfulness. Then potential advantages. Then these are all the model parameters. It is trained on 7 billion parameters. Model architecture based on generative pre-trained transformer GPT, similar to that of ChatGPT. Okay. Then training data, fine-tuned on a combination of public and synthetic data sets. Okay. Then optimization method. So direct preference optimization instead of traditional reinforcement learning. So these are some of the model metrics. Okay. Then there is DILO-GPT. DILO-GPT is a short for dialogue generative pre-trained transformer. Is a LLM model specifically designed for generating open-ended and engaging dialogues, developed by Microsoft Research. The key parameters are, it has been trained on 1.5 billion parameters. Number of layers is 36. As you can see, the training data sets is 147 million Reddit conversation threads. Okay, so this is all our configuration key parameters. Okay, then the architecture of it. The transformer-based DILO-GPT employs the transformer architecture, which is a powerful neural network well suited for language processing tasks. It has been trained on encoder-decoder architecture, self-attention mechanism. It is having self-attention mechanism. Okay, self-attention mechanism for capturing the long-range dependencies within the text. Yeah, and then there is masked language modeling. Okay, so DILO-GPT is pre-trained using MLM, which we have seen in the previous lecture. Yes, where we have used MLM, masked language modeling. Okay, where it learns to predict the missing words in the text sequence. This enhances its ability to understand the language structure and semantics. Okay, so these are some of the key features of key aspects, that is fluent and natural interaction, multi-turn conversation, so on and so forth. Then there is BioGPT. So BioGPT it has been trained on 1.5 billion parameter. Number of layers are 36. Hidden sizes are 1024. Then this is vocabulary size 50,000 to 57 words plus 4004 biomedical entities in it. Okay. Then there is maximum sequence length is 1024. And the training data set, it has been trained on 18 billion words of biomedical text and code. Okay. So this is its architecture. It is having transformer architecture. Okay. Encoder decoder, same as that of previous one. It is having self-attention mechanism for long range dependencies within the text. Okay. Then there is domain specific pre-training. That is BioGPT is pre-trained on a massive data sets of biomedical text and code only. Okay. So enabling it to acquire a deep understanding of biomedical term or biomedical terminologies, concepts, and relationship between the words. Okay. So this BioGPT, the name says it all. Biomedical entity recognition. Okay. BioGPTs accurately identify and classify the biomedical entities such as genes, proteins, diseases, medications within the text. Okay, then there is conceptual understanding of biomedical language. It has comprehend the concepts and relationship between the biomedical terms, enabling it to generate more accurate and relevant text and code. So it can generate code generation also. It can generate code including Python, R. Okay. Then creative text generation. It can it can do poem also in that, scripts, musical pieces in emails, letters, drawing on its knowledge of biomedical concepts and languages. Okay. So potential applications, as we can see, it can be used for biomedical text mining, drug discovery, clinical decision support, bioinformatics research, personalized medicine. We can use it for so on and so forth task. Then there is Nemotron. Nemotron 3, 8 billion base 4K is a large language foundation model for enterprises to build custom LLMs. Okay, the architecture of it is based on Transformer XL base. Nemotron builds on Transformer XL architecture, known for its ability to model long-range dependencies in the text. Hybrid sparse attention. It incorporates a novel hybrid sparse attention mechanism that combines dense and sparse attention patterns, aiming for both context awareness and computational efficiency. Okay. And here it is used for decoder only. Unlike traditional models, it depends on encoder-decoder architecture, but Nemotron employs only on decoder. Okay, directly generating text from input sequence. Okay, it is not taking encoder into account. What encoder do? Encoder takes the input. Okay, it convert that into that tokens, and then decoder will generate it. But here directly what do? Directly text is text from the we will take the text and then directly generate it. Okay. Then there is key parameters. Model sizes 10 billion. So this is how the key parameters is on. Then there is Nemotron. Nemotron's input embeddings. So model receives an input text sequences, converting the words into numerical representations. Then there is positional encoding. The model adds positional information to the embeddings, indicating the words order and context. Hybrid sparse attention. The decoder processes the input sequence iteratively, attending to relevant parts of the input, and previously generated the text using a combination of dense and sparse attention mechanism. Okay, so this is how it is. Then there is output generation and conclusions. Then there is Bloom. Bloom or Big Science Language Open Science Open Access Multilingual Language Model is a revolutionary force in the world of LLMs. Its sheer size, compared with groundbreaking features and open access availabilities, makes it a game changer in the field of artificial intelligence. Okay, so these are all the model sizes. It has been trained on 171. It has been trained on 176 billion parameter, okay, which is very huge. Then numbers of layers is 340, hidden sizes, attention heads. So this is all it is, you know. Then the workflow of it is input embedding. The text input is converted into a numerical representation. Whatever the text format we have, okay, that will be converted into an embedding numerical representation, and then preserving the semantic meaning to it. We will preserve the semantic meaning to it. Then positional encoding. Positional encoding is added to indicate the word order and context. Then there is encoder processing. The encoder processes the embedded input sequence, capturing the relationship between the words and building a comprehensive understanding of the text. Then there is sparse attention mechanism, strategically focuses on the most relevant parts of the input, enhancing its efficiency. Then there is decoder generation. The decoder iteratively generates the output text word by word using the encoded information and prompts or instructions. Okay. Then there are sparse attention mechanism, which will guide the encoder. It will focus on relevant aspects of the input and previously generated the text. At each step, the model predicts the next word. What will be the next word based on the understanding and context. Okay. So this is what I have read is the encoder and decoder thing only. Okay. So firstly, what will input do? Input will take the input. Encoder will take that input and it will segregate it into it will have their attention mechanism in it. Okay. And then what decoder will do? Decoder will then generate it. Okay. Based on the input. Okay, then output. The process repeats until a complete text is generated, meeting the requirement of text or user request. So these are some of the key takeaways. So before that, we can also explore for what we have kept. Okay, so these are the key takeaways. I think every slide is completed. Everything we have taken. So these are the key takeaways from us. Okay, we have learned about the virtualization and its benefit. Okay, we have learned the foundation models basically, and we have learned all the I think 40 foundation models we have completed. Okay, so this is all we have completed so far, and we will see you in next lecture for the new topic. Okay, this is all for today. Thank you.